Okay, so I feel like we don't do enough at the end, so we can start at like the end and then come up.
Oh, are we done? Is this the practice test?
Yes, we're going over the practice test. We'll start with 13, go down to 14, 15, then we'll do we'll move our way back up. Cool.
That literally is the problem.
That's exactly the problem from the practice test.
Wait.
Yep. So theoretically, you did this when you were studying for the test that was supposed to be for today that you don't do at 9 a.m. last night about. So everyone should have did this right? Okay, cool. Also, your review, because there's 4 homework problems, due the day of the test. It also teaches some of this. Okay, so tomorrow is your chapter 4 test. Now, I moved it a day. So what this means is you should, get going, all right? You gotta study, gotta go through some things, look what you don't know. Okay. I will tell you, for the test, it's 12 problems. I give you 2 about related rates. You get to choose the one you want to do. I give you 2 problems about...
Wait, 2 about what?
Related rates, 4.6, and you choose which one you're going to do. I give you 2 problems on 4.4. You choose the one you want to do, which is optimization.
This is embarrassing. I'm going to practice test because I was absent for so many.
Definitely have one. I think I gave it to 8 to give to you.
You're right about the embarrassing stuff.
Yeah, pretty sure. Do you want me to get more?
I can
print more.
I can just write it in here.
Okay.
What did you say the answer was for that thing?
Did you say the thing she was doing last night? Oh, okay, that's it. Cool. What's wrong?
It was 2 plus y over 2y minus.
Well, I'm going over it again to make sure we understand how to do this. DDX.
And this answer is on the test.
No, but it's saying front.
I'm not gonna do that.
Yes.
No. I did that with my intermediate, but I'm not gonna do it with you guys.
Because you paused the class, I can't have access to it.
Got it.
Sorry, I have a question.
There you go.
But I'm gonna pull up my computer just because. How many questions?
Do you? Or I just print this for you.
It's okay, because when I already have like half of it.
Okay. What?
How many questions like 11 and 12 in the
You still need a hash spell?
No. I know you're dying to get them off. So the question I just answered about 4.4, 4.6. Oh, okay. I give you 1 problem about related rates, which is 4.6. I give you 2, but you choose 1. I give you 2 problems on 4.4 optimization. You do 1. I mean, I gotta look at the test again, see what I did. But that's that one specifically is in my memory because I'm at least get 1. Please get 1 of them.
Do we get extra credit?
No. Nope.
Nice try, Hannah.
I used to do that, but then, whatever. Okay, so take the derivative. So we have 2y times dy dx. There's implicit differentiating equals 2 plus x dy dx. This is exactly what we just did on the board, but hopefully you can write it down this time. Okay. Move everything to the same side. 2y times dy dx minus x dy dx. This is why I gave you all the review that's in the book, so you don't forget implicit, so you don't forget product rule. Okay.
That was a tricky one.
X times y?
Yeah, that's sneaky.
I mean,
because I took the derivative of x and I was like, oh, it's 1. So then
if you look at, it's either your test or one of the quizzes from chapter 3. It's on there.
yeah, I did that.
In the notes, yeah. Okay, let's keep going. So, factor out dy dx. Hopefully we are getting better at this. I started making your next topic on MyJag.
Why is there no dy over dx after the y?
Because the derivative of x is 1, because we're taking it with respect to x. The derivative of x with respect to x is 1. Derivative of y with respect to x, take the derivative of y, right? For instance, y squared derivative is 2y and then times whatever, however y is changing with respect to x. Yeah. So, more or less, whatever thing you're taking the derivative with respect to, so the thing on the bottom, when you hit that variable, you just do the normal variable.
But then why is the x, why is it x times dy?
Because product rule, x times the derivative of y plus y times the derivative of x. Alright, if this is u and this is v, this is u v prime plus u prime, oops, sorry, I'm gonna write it this way, plus v times u prime. That's literally what it is, product rule. Okay, so we found it. Now, hopefully you remember how to do this. Find the slope of the tangent line at the point. How do I solve this problem?
You plug in points.
Plug in the points. Wonderful. Find the slope of the tangent line, aka what you just found, and you're plugging in for x and for y. So, plug in 1 for x, plug in 2 for y. So, I have, let's see, dy dx evaluating at, yeah, it's 4/3, 1 comma 2. 2 plus 2 over 2 times 2 minus 1. So it's 4/3. Like, these are meant to be easy points. You just plug in and go. That's it. 15, write the equation of the tangent and normal lines. Do we know what the equation of the tangent is?
Oh, that one parallel.
Literally the thing we just found, right? The slope of the tangent is 4/3, and then we can use point slope, and that's easy. You don't have to go through and simplify. It's a waste of your time. I just need an equation of a line. Easiest is point slope, because we have a point, 1 comma 2. We have a slope, 4/3. So y minus y1, 2, equals 4/3 times x minus x1, which is just 1. So this is for A. And guess what? How do I change it to do B? Negative reciprocal. There you go. That's it. These are supposed to be easy points.
That one.
No, issue is if you forget how to write an equation of a line, if you forget normal and tangent are opposite reciprocal for slope. Yeah, exactly. I don't hide the posters on purpose because I want you to use powers of observation. Like, if you are aware enough of your surroundings, cool, use that. It's kind of a goal. Teach you how to be aware of your surroundings, especially on the senior trip. Don't fall off the side of a rock. Don't run into someone who then goes off the side of a rock when someone's walking. When someone's walking and on the path coming towards you, scoot to the side and let them pass. Don't just ram them with your shoulder and then be like, huh. Okay, that was a little too specific. Let's keep going. I'm so mad.
Did people get knocked off the cliff?
Like someone ran into you and like,
No. One of our students rammed into a stranger and went, "Meh," whatever. And of course, I was like 30 feet behind, so the people were complaining about the kids to each other by the time they walked by me, and I was like, these kids.
these kids.
Oh man, no self-awareness. Okay.
Number 14?
14, 12, what?
Wow, what action was that?
What?
I have a quick question.
12, 14, what you want? What?
Okay, well, maybe 12?
Why is it 2 plus 2? Should it be 2 plus 1?
No, because y is 2, x is 1.
X comma y. Yeah. Oh, I wrote it wrong.
We're plugging into here. It's all cool. Okay, let's do this. Sasha flies a kite at a height of 300 feet. If the wind carrying the kite... Okay, what type of problem is this? What's going on here? A triangle. We're changing rates. Is going to be related rates, right? Because I see the kite's flying. We don't know how fast the string is going to be let out. Crazy. Okay, related rates. So,
2 of these types of problems or 1 of them?
so there's... I give you 2 and you choose 1.
Okay.
Yeah. After, maybe when there's like 5 minutes left of class, I'll go through and I'll, like, tell you more about the tests, because I made them, so I did it, yeah. Got ready this morning. Okay. Things we know. It's a triangle, right? She's flying her kite 300 feet. The wind carries it horizontally away at a certain rate. How fast does she have to let out the string? So that way, how fast, so when it's like 500 feet away from her. Okay, so there's going to be a triangle. Right, so at a time, it's 300 feet above her. We want to know, let's see. So it's going to stay constant at 300 feet, but then horizontally, it's going to be changing, right? dx dt is going to be increasing at 25 feet per second. because it's like going sideways. What we're looking for is this z, right? The hypotenuse. We want to know how fast she has to let out the string. So when it's 500 feet away from her. So when z, the hypotenuse, is equal to 500 feet, like how fast is she letting out the string at that point? Have you ever flown a kite and all of a sudden the wind picks it up? Yeah, and all of a sudden you're being pulled across the ground. It's great. So
Sounds very personal.
when I was a child, I was a very small child then. Okay, so when z is 500 feet, y is 300. What's our x at that point? 300 feet plus x squared is equal to 500 squared. Do you recognize this triangle?
Oh, like 3, 4, 5.
3, 4, 5. So my x is going to be 400 feet. So this is like our snapshot, right? Have you ever screenshot someone's messages to you on Snapchat? This is exactly what's happening here. At this one,
Snapchat, you have to use a second phone.
well, or unless you just want to be bold and let them know that you screenshot what they said. That way they never say that stuff to you again. Okay.
Or you can do this thing.
I feel like I'm direct with people. I'm honest with you guys. I'm very direct to you. Okay, let's keep going.
If you put,
It's the last.
Mr. O'Brien, if once the Snapchat loads, you put your phone on airplane mode, and you turn the phone all the way off, and then reload it, and open it, it won't see that they snapped.
Yeah, I don't care. I like them knowing that I
It takes
snapped
like
it.
12 seconds.
It's a waste of my 12 seconds.
Yeah.
I'll gladly. Okay, so this went off the rails. I'm trying to make this relatable to you so you understand what the hell's going on, right? So the whole thing of like taking a snapshot, a screenshot. Hannah, literally stop talking. Okay, so when you're taking a screenshot, it is at that moment. This is what the triangle looks like. We know the kite is moving, but at that one moment we're taking a picture, like we have the actual dimensions. So I'm trying to be clear, like when we actually know the distances, when we're like things are changing, okay? Because that will come into play. So what we're trying to find is how fast it's being let out. So what we're trying to find is dz dt, aka how much is our hypotenuse growing? How much is the string being let out? When? At this certain time, at this certain snapshot time, how fast is it being let out? Yes.
Isn't DZ?
Yeah.
So
I need a way to relate. A way to relate x and y and z. We can use exactly. Most times with these problems, you're going to be using area or Pythagorean theorem, something geometry. Literally, geometry is the solution to these problems. So I'm going to have x squared plus y squared equals z squared. And I want to take the derivative with respect to what? These with time, right? We're taking the derivative with respect to time. We want to see how everything is changing with respect to time. What's constant here? Is x changing? Yes, the wind is blowing it horizontally. Is y changing?
why is static?
Y is static. It's gonna be 300 feet high. It's gonna be 300 feet high. Even when it blows across, it's gonna stay the same height. It's just gonna like be going across.
How do we know that?
She flies at 300. It doesn't tell us that it's moving up or down.
Okay.
So you gotta kind of assume. So what this means is we have x squared plus 300 squared is equal to z squared. Now if we go through and take the derivative with respect to time. So we have to use some implicit differentiation, right? So the x is changing. It's increasing at 25 feet per second. At our snapshot, it's 400 feet. But that's not really what it is. It's moving.
So why did we find it?
Because when we take our derivative, you'll see 2 times x times. So we have to have the actual value.
So don't you fill? So you only fill in the constant. I'm going to say this concept, but you fill in the constant before you do the derivative, and then you fill in the like snapshot.
Yes, at the end. So you fill in the things that are actually constant, not moving, metal constructs, right? Our funnel, like it's made out of metal, it's not changing. The water pouring in is changing. Here, our height, it's staying 300 feet high. That's not changing. But how far horizontally away it is, that's changing. The distance from the girl to the kite, how much string she has to let out, that's changing. So derivative of 300 squared, well, it's just 0. It's derivative of a constant. To get dz dt by itself, just divide by 2z. So I have 2x over 2z times dx dt is equal to dz dt. So guess what? The 2 cancels out. So if I just take x over z times dx dt, we will have how fast it's being rolled out, yeah. Just fill in the values. You don't even need a calculator. 400 divided by 500, cross out the hundreds. 4 quarters is 100. 100 divided by 5 is 20. There you go. What? So I divided both sides up here by 2z. So I was trying to get this by itself. So I was trying to make it clear my z's and my 2's. Yes?
Okay, so let's say for a problem I switch like the 300 feet and 500 feet, like I put 300 on the hypotenuse and 500 on the side. Is that just all wrong?
Yeah, because your hypotenuse has to be the biggest side.
So like in this triangle,
Like, I would give you as much credit as I could,
okay.
but like, draw the picture, you know?
Like in this triangle, where would she be?
She is,
The triangle.
this is her. This is the girl.
Okay. Okay.
This is her kite. It is moving to the right.
Okay.
It starts right here, then it goes to the side. There you go. Beautiful art. All right. So,
You have to simplify more.
yes. Hold on. Pause. So she has a question. It may be your same question. When I said you must be focused today, I meant it. Literally, 8 people emailed me for an extension. So these 8 people should have their mouths shut, listening. Yes, because I scheduled the whole semester, and now I'm like, well, screwed. All right, shot myself in the foot, but I want you to be successful. What that means, think to yourself, I know who asked for an extension. I have an email, and I see who's talking off task. Not a good look. Don't make me regret moving the test. What? Okay, she has a question. It may be your question.
It's kind of a stupid question, but for the dx dt, when you find that it's like 25, I'm confused with how like that has like the derivative with the z dash.
So we're looking for the derivative with z, right? Z is the string. So we don't know how fast is the string being let out. How much is that hypotenuse moving?
Okay.
So drawing the picture helps you like put variables to it. Okay, we're gonna try number 11.
How come you don't put it in the 25? Oh, you do.
Yeah, I put everything back in right here. Okay. We can try another related rates problem. Number 11. Yeah. Yeah, I still just want to like get going. Okay. Try number 11. So hopefully you're seeing like the types of problems I can ask you. So walkers A and B are walking on straight streets that meet at right angles. So the picture is given to you. If I didn't give you a picture, I would have to tell you how they're moving. So that way you drew it correctly. Literally, remember I said, oh, the police car is approaching from the north. Blah, blah, blah. Car is moving to the east. I have to give you the directions or give you a picture. So we have A is moving. Oh, it's moving down. Who was with me during bonus? Yeah. So I had it moving up. That's why that is different. I got a different answer than they did. So I had arrow going up. My bad. I can't see. All right. So what's wrong? No. Because the angle between them is here. As A is coming down, the other guy is moving out. So the angle is going to get less, but we want to know at what rate is it getting less. Yeah. So in case you're wondering, this is like one of the very simplest problems you can do for like trajectories and like orbital mechanics. If you think about a satellite going around the Earth, like it's moving, there's so many different vectors, so many different like movements going and related rates. Okay, so how is it spinning? How is it moving this way? So orbital mechanics are really fun because it's like 20 different related rates all at once. But you guys are, technically this is baby rocket science, so look at you, all right? Hopefully that's confidence. All right, so A is going down. It's approaching the intersection at 2 meters per second, so it's going down. So let's see, I'm going to call this Y. So dy dt is going to be negative 2 meters per second because we're going down. And then the b is moving away from the intersection 1 meter per second. So going to the right is positive. And so I'll say this is dx dt. It's just easy to keep everything in terms of x and y because that's what you're used to. Okay. So dx dt, how it's moving with respect to time. At what rate is the angle changing when a is 10 meters from the intersection? Okay, ready? This is snapshot time. So this is not always what the lengths are going to be, but at the moment we take a picture, this is what it's at. So our when y is 10 meters and x is 20, all right, from the intersection. At that moment, how is the degree changing? And we are going to, in degrees per second. That was my bad, I put in radians. So, express your answers in degrees per second to the nearest degree. Okay. So, it'd be great to have some relation. What is the relation between, the vertical, the horizontal, and the angle? The angle, Pythagorean tells you the hypotenuse length. Tangent. We want to relate the degree to the sides. So tangent of theta is going to be y over x, opposite over adjacent. Speaking of tangent, okay, so at our snapshot, at the moment we took a picture of our triangle. What is our angle? Well, let's see, tan of theta is equal to 10 over 20. 10 over 20. So if you put this into your calculator, you would have to put tan inverse of 10 over 20. We want to know the angle. So the angle would be 0.4636. Should be. We can test it.
I got 26.56.
Did I put it in radians? I probably put it in radians. No, I know myself. I tend to work in radians and disregard my own directions. Yep, let's see.
It says degrees.
Yep, I know, but I disregard my own directions because I like radians. Why did I do this? Come on. Freaking thing. 10. Oh my gosh, what? This is my life. Okay. 10 over 20. Let's make sure I did it correctly. So I'm in degrees. 10 over, oh my gosh, I took tan, not tan inverse. Why did I do that? Tan inverse. 26.56. I'll say 26.57 degrees. 26.57. 26.57. Because that's definitely the radians. That is 26.57 degrees. It says degrees per second. It says degrees per second.
So that's the answer.
No, not at all. This is at our snapshot. At the snapshot, this is the angle I'll be plugging in if I want, something theta. But what we're wanting to really find is d theta dt. Okay, so we went through. This is like, I'm going to box this because this is just like the snapshot. When I'm actually plugging in, if I need x or y or theta, this is what the values I'll be plugging in. But what we're really trying to solve for is how the angle is changing with time. So d theta dt. So we have to take the derivative with respect to time on both sides. Guess what? Chain rule. Because tangent of theta. Tangent, we're doing a function to theta, but then theta itself is a function of time. So I have secant squared theta times d theta dt. And on the right side, y over x, we have to use blank rule. Quotient rule. See, everything's coming back. 100%. Why you have the review from your book, because you must remember this. So, sing it. No, it's fine. I don't want you to sing it. Low d high. So, low x times d high. Derivative of y is just 1 and then times dy dt. Because we're taking the derivative with respect to time. Yes?
Why would you find the derivative of y and x and not plug in -2 and all that stuff? Or would you plug that in?
-2 is dy dt. That is the derivative with respect. So I'm finding everything and then I'll plug in values that I know.
Oh, okay.
minus, let's see, low d high, take high d low dx dt, square the, across the line, square the low. We have the opposite side y and the adjacent side x. Opposite over adjacent. So according to this angle, the opposite side is this guy, the adjacent side is this one. So the opposite side is y, the adjacent is my x. That's why. If this was my angle instead, it would be different.
Wouldn't it be 2 and 1?
Ah, see, that's the derivative. That's how y is changing. That's not what y is actually. Okay, so I want to get d theta by itself, d theta dt by itself. So what can I do? Divide both sides by secant theta. Right? Dividing by multiplying by secant squared theta on both sides. What is 1 over secant squared theta equal to? What's another way of saying it?
Cosine squared.
Cosine squared theta. Yay! Yay! Pre-calculus and the reciprocal functions. Just kidding. Algebra 2, reciprocal functions. Okay, so x times dy dx. That came out way meaner than I meant it to be. I just hope you remember reciprocal functions. Because x is changing with respect to time, right? The guy is walking, increasing x at a rate of 1 meter per second. X is not constant with time, it's increasing as time goes on.
You could also leave secant squared theta as secant squared theta, right? Just put it on.
Yeah. Yeah, that would be fine. Okay, ready? Here's the big kahuna time. We're plugging in all the values. Big kahuna, here we go. D theta dt. So, kahuna, big kahuna. Huh? I've never been to Hawaii, but I'll speak Hawaiian to you. X, at our snapshot, ready? So at our snapshot, we can see how fast the angle is changing because we have all the information about the triangle at that moment, right? We know how fast X is changing, we know how fast Y is changing, we know the length of X, we know the length of Y, we know the angle. Cool, we can find out how fast the degree is changing. So, X is equal to 20, and my Y is changing at a rate of -2. Minusing Y, which is 10 times the rate of 1, yes?
We have dy dx there,
Yeah?
but -2 is dy dt.
That's a T, it should have been a T, I'm sorry. That's a T. Taking a derivative with respect to T. It's good, it's good. Okay, do you have the answer, Shani? Focus. What?
No, not you.
Wait, so let me just plug into the calculator.
Yeah, you plug into the calculator.
About -0.1117.
Negative 0.1. Okay. Nearest degree. Ooh. Oh, this is no wonder. I put my answers in radians. Not bad. So it's like 1/10. So it's like, should be 9 degrees or so. 9. Should be around 9. Let me make sure. So I have 20 times -2 is -40. Okay, let me do some of the math first. So that's -40 minus 10 is -50 over -50 over 400. So that's -1/8. -1/8 times cosine 26.57 squared. Okay. -0.125 times, ready? Watch this magic. So I'm going to do cosine, and then I'm going to square it, just like that. Yeah, whatever. Big magic.
When we grade it, the squares on the other side.
Right, because we wanted to be clear. Let me put this in, and then I'll show you why. So there's common nomenclature, right? Everyone in America drives on the right side of the road. That way no one crashes into each other. If everyone does it the same way, we won't crash. We have the same rules. Oh, it is -0.1. Fun. In degrees. Okay, well, what kind of direction is this?
Goes down one.
Okay. Negative 0.1 degree. Okay, well, whatever. Okay, to answer Gabe's question. So, cosine squared of theta is the same thing as saying cosine of theta squared. Now, sometimes we have it in terms of x. And as you learned in chapter 3, we can do chain rule. Because cosine squared x is not equal to cosine of x squared. Parentheses are very important because you could have cosine of x squared, or did you mean cosine of x and then it being squared? So this is why parentheses are your best friend. So to make sure no one gets confused, right? If it's cosine of x and then being squared, we always write it this way. That's the driving on the right side rule. Everyone does it the same way so we don't screw up. Okay.
Is it all of Europe?
What?
Yeah. All of Europe?
No, just
Wow.
England
No.
and Australia.
Just England?
Australia.
Potentially.
Australia's not part of Europe.
Yeah. Okay. So,
We love you.
what other questions you want to do? 7, 8, 9, 10. There's 4 questions and 4 minutes left.
Oh my god, that was
I feel like, didn't we do 8? We did 8 last time, right?
We did 8.
We did 8, yeah. We already did 10. Okay, let's do 10, yeah.
Alright, bro, it's right there, bro.
Yeah, let's do 10.
Oh, this is exactly.
I think 7 is in our packet. Yeah, it is.
7 is, but so is 10. Roughly.
So can we do 9?
Let's do 9. Yeah. Because, oh, you have something square and you're cutting out little squares. That's exactly from your notes.
What the?
Okay, let's do 9. Of all numbers whose difference is 12, find the 2 that have the minimum product.
Oh my god, so we have to make an equation and then find the derivative of that equation.
Yep, critical point. This is optimization. Whenever you have minimum or, let's see, blah, 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 maximum, that's how you know optimization. So, the minimum, okay, the difference of 2 numbers. So, I'll have one number minus my second, it has to be 12. The difference of 2 is 12. Okay. So, this means, what?
6 minus 6 is definitely not 12.
13 and 1.
6 and negative 6.
Okay.
Yeah.
So if my first number is x, right? My first number is x. Y is just going to be 12, no, x minus 12. So I'm putting it all in terms of one variable, right? If my first number is x, my second number is going to be x minus 12. Okay. So when I want to take the product, right? Because we're trying to minimize the product, this is just going to be x times y. Well, guess what? We just said what y was in terms of x. X minus 12. Product. You're just multiplying them together. Multiply 2 numbers. One is x, one's y.
That's what you're doing.
We're trying to minimize the product because the difference between them is 12. So my first number is x, and the second number is going to be x minus 12. It's just going to be 12 less than my first number. So let me distribute out the x. I have x squared minus 12x. And now when I take the derivative, right, my derivative is going to be 2x minus 12. Yeah, it's just longer. It's easier to just do a polynomial. So we have a critical point at x equals 6. Cool. So we want to find the 2 numbers. So if x equals 6, guess what my second number is going to be? Negative 6. Because y is equal to x minus 12. So y is just going to be 6 minus 12, which is negative 6. They have the minimum product. So negative 6.
Oh, because 6 minus negative 6 plus 6.
Yep. That's optimization. This is 4.4.